So here's a problem where we have to add the fraction -1/6 to the fraction 2/5. And the first question, as always, is what should I do with this negative sign in front of the 1/6? Nudge it upstairs. Yeah, we'll put it on the 1 up in the numerator. That'll make sure that it goes wherever that 1 goes in the process. And doesn't somehow get stuck in 2 places or something. Okay, great. All right, so now I have a problem where I have to add 2 fractions. What do we know about adding fractions? We need to find a common denominator. That was a step that we didn't have to do when we were multiplying or dividing, but which we do have to do when we're adding or subtracting. And what's the shorthand? Yeah, let's just go straight across, multiply the 2 denominators together. It won't always get you the least common denominator, but it will always get you a common denominator, which is all we need to get started. 6 times 5, 30. And so my fractions will have denominators of 30. Now all I have to do is balance out the numerators. And for that, once we've multiplied across the bottoms, we can cross-multiply. Which again, I hate using that terminology, but it works somehow to get the new numerators. So what's my numerator of my first fraction going to be? -1 times 5? -5. So again, the negative is staying with that quantity as we move it along. And then the other numerator? 12. 2 times 6. Great. So now my 2 fractions have common denominators. This is the step where if you're going to screw up adding fractions, it's because probably you forgot this step, right? It's the common denominator step. But now the denominators are common. Now, what's my end game? Add across. Add across the tops. Keep the bottom, add across the top. Well, okay. Now is when we have to reckon with how do I add a negative number to a positive number? Whatever the result of -5 plus 12 is, that is what this numerator needs to be. So yeah, what is it? 7. So all right, that's interesting. How did you know it was 7?
When it's a negative, you essentially subtract, but if you were to switch it around, it'd be like 12 minus 5.
Okay, great. So the first thing you observed is that I'm adding together 2 numbers that have different signs, right? One of them is positive, I'm adding one that's negative. Okay? And anytime we're adding 2 numbers with mixed signs, maybe I'll make a little chart with this like we did for multiplication. Whenever we're adding 2 numbers that have different signs, it turns into not really an addition problem, but a subtraction problem. Okay? So let's puzzle our way through that. So if I'm going to add, if I add a positive number to a positive number, we know what to do there, right? We just add the 2 quantities, and the result is positive. But here we're adding a positive number and a negative number. And so do we know right off the bat whether this sum is going to be positive or negative? Not necessarily. I mean, that's kind of a second level concern. The first level concern should be that anytime we're adding 2 numbers with different signs, we should think of it like a subtraction problem, not an addition problem. So that we're not going to get a 17 as part of our answer. We're going to get a 7, some form of a 7, either a positive 7 or a negative 7. And so it's going to be, of course, the same thing if I add the other direction, a negative plus a positive or a positive plus a negative. Both of those turn into subtraction problems. So that's the first thing to notice, is that if I ignore signs, now I know I'm going to have some flavor of 7 because I'm adding 2 things with opposite signs. Now, how do I know whether it's a positive 7 or a negative 7? I think we alluded to this earlier. Yeah.
Which number is there?
Yeah. Look at which number has a larger absolute value, is the way a mathematician would say it. Okay. So between 12 and -5, what are the absolute values? And I'm going to use that term specifically right now so that we have a frame of reference for it later on. What are the absolute values of these numbers? Absolute value. What's the absolute value of 12? 12. What's the absolute value of -5? 5. Absolute value measures how far away from 0 a number is on the number line. Okay? So it's a measure kind of size, if you like. Right? So 12 has more size. It has more absolute value. It has more quantity inside of it than 5 does. And so the sign rule is that the sign of the sum is the sign of whichever has the larger value. And so in this case, because the 12 was positive, and it had the larger value, my sum was positive. Another way to look at that, I like to use a thermometer metaphor or something like that. So if this is my thermometer and here's 0 degrees on it, then maybe I have -5. So -5 is going to be down here below 0. And when I add 12 to -5, what I'm really doing is I'm moving up on the scale 12 places. -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. So we started below 0 on the scale, but we went north, if you like, so much quantity that we ended up on the other side of 0 than where we started. So -5 plus 12 ends up leaping over 0 and becoming positive 7. So whichever way you like to process that is how you can model it. And so that's the case whether we're adding a negative and a positive or whether we're adding a positive and a negative. The sign of the sum is the sign of whichever has larger absolute value. So here's a similar problem. The difference being that now we've traded out what used to be addition for subtraction. So what I'd like to do is take -3/10 and subtract 1/6 from it. So what's going to be different? How should I approach this subtraction problem? Or maybe what's the same? Like what do we want to do as our first step here? Yeah, like with our last example, because it's a subtraction problem, that really means it's an addition problem in disguise, and that means that we need common denominators. So maybe the first thing we'd want to do is find a common denominator, which remember we can always do by multiplying across the denominators. It may not be the simplest way to do it, but I think it's the most straightforward. So we can bring both of these fractions up to have denominators of 60. What do I want to do with this negative sign out here in the front? Yeah, let's bump it upstairs, just so that it lives in one place and it becomes part of our arithmetic. So I'll put it up on the 3 to make that -3. And then to get our numerators, we'll just multiply diagonally. -3 times 6. That'll give me a -18. And vice versa, 10 times 1. That'll give me 10. Okay. And so now again, we're in this realm where when we take the next step of, in this case, subtracting, used to be adding, but when we subtract across the tops and keep the bottoms, now we have a subtraction problem involving numbers with different signs. -18 minus 10. On our sign chart, this is this missing box down here in the bottom. So we're doing -18 minus 10. Well, first of all, this doesn't look like an addition problem yet. It looks like a subtraction problem. So similar to division, how can I change the subtraction problem to be addition problem instead? Yes, keep, change, flip. Same process as trading out division for multiplication. It's just that we need to reinterpret the meaning of the words change and flip. Okay. So let's take a look at that for a second. Keep, change, flip. So keep, just like it did when we were looking at division, means to take that first quantity and make it the same. Just don't do anything with our -18. So we're going to keep that as it is. When we were doing division, we needed to change the division sign for multiplication. Here, what should I change? Yeah, we're going to change subtraction to addition. So here, change just means to reverse the type of sign into its opposite. So where division became multiplication, here subtraction is going to become addition. And then the last word here to reinterpret is flip. In what sense do I want to flip the number 10? Make it -10. Right. So the very same keep, change, and flip process, just applied to addition and subtraction arithmetic instead of multiplication and division arithmetic, can trade a subtraction problem for an addition problem. And now we can see it for what it is, an addition problem where both of the summands are negative. Negative plus negative. Well, does negative plus negative become positive? We know negative times negative becomes positive. But yeah, so what's this one, whoops, what's this one going to do? Let me go back to this thermometer analogy. So in our thermometer analogy, we're starting with, if I label 0 up here, we're starting with negative 18, which is somewhere down here. And then I'm adding negative 10. Is that going to move me north or south on the thermometer? It's going to move me south. So I'm going south, and I started south of 0. So if I subtract 10 from negative 18, I'm going to move even further away from 0 than I was to begin with. And so is my answer going to be positive, or is my answer going to be negative? My answer is negative. So there's the only other guarantee that we can make in addition and subtraction with numbers of positive and negative signs, right? We can guarantee that when I add two positives, I get a positive. We can also guarantee that anytime I add two negatives, I'm going to get a negative. And my only last question is negative what in this case? 28. How do we get 28? By adding the absolute values of these two numbers. Because in a way, when I add two numbers with the same sign, both of those numbers are pulling in the same direction away from 0. In the case of positive numbers, we're all pulling toward the positive direction. And so they combine their forces and we add their absolute values. Same thing with adding two negatives. We're pulling in the same direction away from 0 on the negative side, and they combine their forces. It's when we have numbers of opposite signs that we create a tug of war, right? And whichever number has the larger tug is the one that's going to get the sign at the end of the day. But adding two numbers with the same sign, those two numbers are working together in the same direction. So we can guarantee that a negative plus a negative is always negative. And a positive plus a positive is always positive. It's only when the numbers have opposite signs that we have a subtraction problem and a judgment to make about which one of the two is more. So all of that means, coming back to our fraction problem, that this numerator is negative 28, my denominator is 60, and is that lowest terms? Why is it not lowest terms?
That it can be reduced.
Yeah. What can we reduce it by? What's a common factor of both 28 and 60? 4. So 60 is 4 times 15. 28 is 4 times 7. And so how do we actually do that reduction? Just divide both numerator and denominator by 4. Because again, anytime you multiply or divide a fraction's numerator and denominator by the same quantity, the result is a number that has the same value as the fraction that we started with. Negative 28 divided by 4 is going to give me negative 7, and 60 divided by 4 gives me that 15. And then that's that. So I think that's the other thing about fraction problems that causes people to not like fraction problems after a while, is that not only does it require us to attend to the arithmetic of fractions, but when there are negative signs floating around, it's going to stick us right in that weak spot too, right, of adding and subtracting numbers with positives and negatives. So this is kind of a perfect storm of arithmetic when we have to do problems like this. And the more exposure you get, the more practice you get to, first of all, choosing an effective strategy like common denominators and cross multiplication and so forth, choosing the right strategy, and then paying close attention to negative signs along the way. That combination is going to get you through when anytime